Okay, seventh grade. We are gonna do some notes, but I can't remember where we were, so I'm going to start here. I feel like we had started this and then did not finish it because these are the types of fossils. And if you have your book, you should probably turn to page 190 because that's the page that I am on currently. So just to see some pictures, yes, there's pictures on the screen as well, but here, let me Okay, so the first type of fossil is mineralization. Remember that was petrified wood or petrified anything. You could have petrified bone as well. It's just be heavy. It's like all the bone tissue now turns into rock, so that's why it's a lot heavier. I'm positive we did this slide. So I'm going to move on to carbonization. Carbonization is when fossil films made by carbonization are usually black or dark brown. It's basically plant. A lot of carbon is left over. A lot of plants are like this. They're kind of smushed over time and you're left with the carbon outline because we are made of carbon. Anything living is made of carbon, mostly of carbon. So that's kind of what's the only thing that's left of that whole organism. The next type of fossil is molds and casts. So I'm on the next page of your notes. Molds and casts. Molds and casts are impressions in the mud, and the cement hardens. A mold forms. A cast would be then a fossil copy of an organism. So you can either have a mold or you can have a cast. A cast would be more um, the copy of the whole bone. They make casts sometimes of like dinosaur like heads and things, and it's like a fake fossil essentially because it's just like the form of what it looked like. That would be a mold and a cast. Next one, trace fossil. That's when something kind of scurries around and then it's left over. So that fossil is left over. It's the tracks of an animal. That's on page 191. You can see there was like a really cool little dinosaur footprint in there. Mine, I think that's a snake on the screen right there. That's just a different type of fossil that they find. Again, we can find these around here too. We do have some over in Mrs. Hintz's room. When I come back, I can show you that we do have some imprints and stuff like that of things that people have found. And the last type of fossil is original material. And that's when something's preserved in ice, like the whole thing is. They have found frozen mammoths or tigers that have been completely frozen. If they were to unthaw, they would be completely, they would start like decomposing immediately. So they have to keep them frozen. Or like that picture is a picture of an insect in amber. Again, it's completely um, preserved. So the whole thing is preserved. That's original material. When I get back again, I will show you there was a video of like the frozen mammoth. They look like little, I mean, it's a complete mammoth. So they believe like that one, I think, is a little baby and it was walking on the ice and it fell through the ice and then froze immediately. Okay. Scientists also have found that original material preserved in bone of a dinosaur that lived 70 million years ago. So these things can last a really long time. It's not just like a short period of time. 70 million years is one that they have found. Um, okay. So we're going to move on from the fossils to determine fossil age. So I'm currently looking at your notes. If you don't have one, I do have a copy up here, but we're going to have to make a copy because I'm not positive if I have another one. So if you need to make a copy, that's fine, but you need to get on top of that. Okay, so determine fossil age. So this was a question before. How do they determine the fossil's age? There's two different ways. One is more accurate than the other. They date the fossils by the rock around them. That's the first one. It's relative dating. That's just saying like they determine the age of the rock layers. So they just determine like a quick determination that if it's on the bottom in the rock, it's the oldest. The top is the youngest. So even if you look, for instance, like if I go to the Badlands and I'm looking, the bottom layers are the oldest types of rocks. And then as you go up, that's the younger rocks up there. So like the Grand Canyon, they always say you're looking back in time because you can see all those rock layers, and that is all time periods. Okay. A more accurate, this is on page 192. You can see that they have like dated the rocks. In on page 192, the last part is the absolute age dating, and that's radioactive decay. And I kind of mentioned that I think in fourth hour, where absolute age dating is more precise than relative age dating. Scientists take advantage of radioactive decay, a natural clock-like process in rocks to learn rocks' absolute age. So there's certain elements that decay over time, and they know which these elements are, and they can test for them. So once they test for them, they can determine then how old something is, depending on how much element is in the rock. Um, if you've ever heard of carbon dating, that's exactly what they are doing. They're seeing how much carbon is left in an organism because carbon decays, certain types of carbon decay over time. So they can see how old something is by how much carbon is in there. Now, eventually, all that carbon is gone, so they can't use carbon dating. So then they have to use a different element to figure out absolute age. So there's relative dating and absolute age. Then this is probably the craziest thing to think of, and we kind of touched on this the other day, time. So microscopic unicellular organisms have been found in rock 3.4 billion years old. So at this time, that would be one of the earliest things that we have found, 3.4 billion years old. Now, the Earth is around 4.5, 4.6 billion years old. So we have not found anything to date that, but they can use rocks to determine that. So they're not saying that they can't date the rocks. They have not found anything that was a cell living after 3.4 billion years. So I'm on page 193, and I do kind of want you to take a look at page 193 because it's the geologic time scale. You won't have to know it, but I do want you to see what basically was nothing on Earth for a long period of time. So 4.6 or 4.5 billion years ago to 542 million years ago. Not a whole lot was going on. Probably we had some unicellular organisms, some eukaryotic cell organisms. We had some jellyfish, like little sea life. And then 542 million years ago, that's when little more things started happening. So again, the Earth has been around a long time, and not a whole lot has been going on in Earth's time, except for like right now. Okay. With that, we've had some extinctions, and we always talk about the dinosaurs dying, but I want you to know that there was a lot more extinctions than just the dinosaurs. It occurs when last of species dies. 5 mass extinctions have happened in our environment, and that's on page 194. And you can see those 5 because it kind of like a drop in numbers of species. So something happened, resources and environments change. Yes, we know the dinosaurs. Now, did this stuff die just immediately? No. It took over time, things died, but we say it's like really quickly. But remember, the dinosaurs didn't just one day all become extinct. Just like not all the sea life became extinct. Something changed, their environment changed that they couldn't live there anymore. So eventually those species went away over thousands and millions of years. This wasn't just a one day occurrence. But I think movies have dictated that we think that like the asteroid hit and boom, all the dinosaurs were gone. No, the asteroid hit, yes, some died, but over time those dinosaurs had nothing to eat, which then eventually killed them because their environment changed too much, their resources ended, and they could no longer be successful. Biological evolution, and that's all leads extinctions and change over time leads to this next section, which is biological evolution, the change over time in populations. Charles Darwin, and we're going to talk about him, was credited for a lot of this theory, but he wasn't the only one that thought this. And there's many people that have proven his thoughts to be relatively true. So he kind of was the one that started this whole thought of things are changing over time, but he wasn't the only one, but a lot of books just give him the credit. Okay, so we did section 1. So you should be all the way to section 2 in your notes. What you are going to do, so if you filled out these notes, you can either work on your web quest from yesterday. I'm not positive how far everybody got on that. I think I said that the web quest is going to be due. We'll just say everything. This is going to be due on Thursday, just because if you have any questions. So the web quest is due on Thursday. When you're done with notes and you're done with the web quest, I do have a worksheet for you to work on One section is from lesson 1. So we're in chapter 6. So one section is from lesson 1. The other section is from lesson 2. The lesson 2 one is like a note-taking sheet. So you kind of have to read. The purpose of it is I want you to read section 2 and then fill that in. So that worksheet is going to be due on Friday, just in case there are some questions. So WebQuest due on Thursday. That worksheet you get today is going to be due on Friday. And not to forget that some of you might not have turned in your vocab for chapter 6. So please look at PowerSchool and get that in. That was due Tuesday. Okay, I will write this all out for Mrs. Yunker to say as well, but I just wanted to reiterate when things are due. Be good.